Welcome back. In this video, you'll learn more about advanced techniques for processing text. Syntax and semantics are two techniques used in understanding language. Syntax is the grammatical structure, while semantics is the meaning. A sentence could be grammatically correct, but makes no sense. For example, the sentence, "Dogs love to run," makes sense. But the sentence, "Dogs ride bananas," doesn't make sense. Now, both are grammatically correct, but only the first sentence is semantically correct. Here are some important considerations when building applications such as chatbots, personal assistants, or search engines. First, consider word order and meaning. Syntactical analysis looks at how words depend on their surrounding words. Changing the word order might make it difficult to understand the sentence. For example, the sentence, "Alexa, in the Who won Ping Pong 2018?" has the same words as the example, but makes no sense. Next, consider whether you should keep stop words. Removing stop words might be good for reducing the dimensions, but doing this can alter the meaning of the sentence. Make sure that you understand the morphology of words. Both stemming and lemmatization will change the words and modify the grammar of the sentence. Finally, identify the parts of speech in a sentence. It's important to identify the correct parts of speech for understanding the correct meaning of a word. For example, consider these two sentences. "Both my dog loves his stick and you need to stick to a schedule" contain the same word stick. In the first example, stick is a noun, but in the second example, it's a verb. All these considerations are important when working out meaning. For example, say that you ask Alexa, "Who won the ping pong in 2018? Alexa needs to understand the structure of the question to answer it. The phrase ping pong relates to an event, and the phrase in 2018 refers to a time frame. The event and the time frame have a relationship to each other. You can find these dependencies by parsing the text. Parts of speech tagging, or POS tagging, means labeling words with the appropriate parts of speech. Parts of speech include verbs, nouns, adjectives, adverbs, pronouns, prepositions, conjunctions, interjections, numericals, or determiners. POS tagging is usually done with the help of a pre-trained tagger. Most taggers use the list of tags from the popular pin tree break tag set. To correctly identify the correct tag, the previous and next words are considered. Understanding the structure of the sentence is a key step when you want to extract information from text, such as names, events, and locations. All other techniques use part of speech tags to parse a sentence. To understand common grammatical patterns, you need to divide the words into groups called constituents. This is done based on the role of the word in a sentence. English has three main constituencies that are used in NLP. Now, the first constituency is the noun phrase, which is a phrase built around a single noun. Some examples of this are, "A packet of chips was included with lunch," or "That music video is an international phenomenon." The second constituency is the verb phrase, which is a verbal part of a clause. Here's an example. "She had been living in Hong Kong." The third and final constituency is the prepositional phrase, which is a phrase where the preposition always comes at the beginning. An example is, "I long to live near the beach." After you tag the parts of speech and the noun, verb, and preposition phrases are detected, you can understand the meaning of the words. Typically, for English, the word order is subject, verb, object, or SVO. The basic idea is that a sentence is about something and it usually involves a subject, a verb, and an object. Most sentences are more complex, but the same parsing rules can be applied. In the previous example, who is the subject. In this case, Alexa deduces that the who must be a table tennis or ping pong team based on the object, the ping pong. Won is the verb. The ping pong in 2018 is the object. With this information, you can begin to answer the question. The goal of core-reference resolution is to identify text mentions that refer to the same underlying object. Core-reference can be anaphoric, which refers to the previous text, or it could be cataphoric, which refers to future text. Understanding what the words he, she, or it refers to is important in understanding text and information systems, chatbots, and virtual assistants like Amazon Alexa. In this last section, you learned about some of the more advanced NLP processing tasks, which include POS tagging, so you can understand the individual components of a sentence, constituency parsing, so you can identify phrases from words, dependency parsing, so you can understand the relationship between the words and phrases, and coreference resolution, so you can identify entity mentions within the text. In later modules, you'll explore some of these topics in more detail. You'll also explore how they're used when you learn about information retrieval and topic modeling. Although specific techniques for these topics aren't covered in this course, they're also useful for building chatbots and virtual assistants. Thanks for watching. In the next video, you'll learn how to distinguish between structured and unstructured data, and you'll also get an overview of 3 different AWS services that you can store text for your NLP application.